Okay, this is the last video for this section in your book. We've been talking about functions and the definition of a function and the test, the vertical line test to determine if something is a function. Then we looked at the domain of a function and how to determine the domain and the possible problems that can occur. Now we want to look at one more aspect of functions, and it's really more of a notational thing than anything else, because we use different notation when writing our functions, and I want to make sure you're clear on all of it. The standard way to write functions that we're probably most used to is something like, if you've seen equations of lines before or whatever, y equals 2x plus 4. Even if you have something like 2x plus 4y equals 8, essentially you write your function in terms of x and y. And a lot of times we explicitly solve our equations for y like this, because then I know this x will give me one y. I plug in a number for x, I get a number for y out. Here I could explicitly solve this for y, and I'd see that it was a function. You don't have to, but you can. But there are different ways to write functions. Suppose I have y equals 2x plus 4, the function we just had. A standard follow-up question, which I'm sure you've all seen, is find y if x equals 2. And then you say, oh, okay, y is equal to 2 times 2 plus 4, because I replace x with 2, which is 2 times 2 plus 4 plus 4, 8. So y equals 8. And that's kind of a standard problem. But mathematicians are inherently lazy, and even writing that much tends to be too much. So we came up with a different way to do this. And essentially we use what's called function notation. And the idea is I replace the y with f of y. That is not f times y, the parentheses mean multiplication sometimes. That is literally just a notational thing that says the function f of the variable, I'm sorry, I said y, the function f of the variable x is equal to 2x plus 4. All I did was literally replace y with f of x. But now, because I do that, I can then say f of 2. All f of 2 is I take the x and I replace it with 2. So I get 2 times 2 plus 4, which is 8. Which is the exact same as what I did here. It's the same thing, it's just different ways of writing it. If you don't like this notation and you're used to the function notation, f of x, just replace y with f of x. If you don't like this notation, replace f of x with y. They're interchangeable, but ultimately you want to be able to use both of them because we go back and forth constantly in math. So I just want to spend a little bit of time kind of messing around with that to make sure we know what's going on. So, suppose I have a couple of functions. F of x equals x squared plus 4. I want a different function, so I'll call my next one g of x. And I'll say that's 3x plus 6. And maybe I'll have an h of x. 2x minus 4. I'm assuming it's obvious how we actually label these things. I call the first one f because it's a function. If I have another one, call it g because it's the next letter in the alphabet. And so on and so forth. But then I can do something like f of 3. That's take this function f, replace x with 3, and I get 3 squared plus 4, which is 9 plus 4, 13. But then I can also do h of 5. Now I use the function h, and I replace x with 5. And I get 2 times 5 minus 4. That's 10 minus 4, which is 6. But then I can also have some more fun with it, and I can say g of delta. That is not a triangle, that's a Greek letter delta. But what is that? Well, by definition, I just take g, the function g, and I replace x with delta. So I get 3 delta plus 6. That's not something we're actually going to use in this class. We actually do use it in later math classes. But the idea is, it doesn't matter what I plug in here, where I evaluate my function in math speak. All I do is figure out which function I'm talking about, f, h, g, and replace x with whatever's in the parentheses. So, if I wanted f of x plus 2, well, that means I take the function f, and anywhere there's an x, I replace it with x plus 2. So I get x plus 2 squared plus 4. The function f takes whatever I plug in, squares it, and adds 4. I plugged in x plus 2, so I squared it and added 4. It's the exact same thing. If I wanted h of happy face, that's not something we'll do in this class, but if I wanted h of happy face, I would take h and I'll replace the x with a happy face. So I get 2 happy face minus 4. One more. Suppose I have f of x squared plus 2x minus 7. That's rather cumbersome, but the principle is the same. I take the function f takes whatever you plug in, squares it and adds 4. So if I plug this in, I would square that and add 4. And again, you just have to get to the point where you understand this is f of x equals x squared plus 4. I just replace the x with this, so I replace the x with that. The exact same. One more thing we can do with this. We'll use the exact same function, so I don't have to come up with more. Once we get the idea of how this function notation works, we can kind of manipulate it. And I can do 3f of 2. But I can just do substitution here. 3f of 2 means 3 times f of 2. What is f of 2? That's the function f when I replace x with 2, which is 2 squared plus 4. And again, you just have to be able to see this is 3 f of 2 right here. I'm just replacing f of 2 with what f of 2 is over there. And then I just solve it out. Order of operations, 2 squared is 4, 4 plus 4 is 8, 8 times 3 is 24. So if I have 4g of 1, the 4 stays where it is, then I multiply by g of 1. Here, we take g, replace x with 1. 3 times 1 plus 6. Let's see, 3 times 1 is 3, 3 plus 6 is 9, 9 times 4 is 36. So the last one, just for fun, suppose I have 2 f of 2 minus 3 h of 2. That's rather cumbersome, but all you do is go step by step and break it down. That is 2 f of 2, take f of x and replace x with 2. So that's 2 squared plus 4 minus 3 h of 2. For h of 2, take h and replace x with 2. That's 2 times 2 minus 4. Now it's all just order of operations. That's 2 times 2 squared is 4, 4 plus 4 is 8, minus 3 times 2 times 2 is 4, 4 minus 4 is 0, and then I get 8 times 2, which is 16, minus 3 times 0 is 0, which is 16. The point being, I can mess around with these things a whole lot. We just have to understand the basic principle. I take a function, y equals x squared plus 4. I replace y with f of x. And then I can do things like f of 2, g of 1, h of 2, 3f of 2, 2f of 2 minus 3h of 2. We're just kind of expanding on the same principle over and over and over again just because it's fun.